I am a PhD student at Shanghai University. I am delighted to present you our ICCV 2023 paper, RFD-ECNet, Extreme Underwater Image Compression with Reference to Feature Dictionary. Due to the limited underwater bandwidth, underwater images need to be compressed extremely. Existing methods do not consider the characteristics of underwater images. The first is that different underwater images contain some common underwater objects at diverse morphologies and sizes, which result in massive redundancy between underwater images. The second is that underwater images present multifarious underwater styles of color shift and distance-dependent clarity. Hence, there are two main drawbacks for existing methods. The first is that they only remove redundancy within an image and do not consider redundancy between different underwater images. The second is that they utilize a unitary compression that cannot handle multifarious underwater styles. Accordingly, we creatively propose to construct an exhaustive underwater dictionary to provide reference for UWI compression to remove redundancy between UWIs. This is our overall compression framework. In the encoder, the input image is downsampled to extract compression features, which are matched with dictionary at multiple scales. For more accurate feature match, we design underwater style normalization based feature match module USN FMM to normalize the dictionary features by utilizing the underwater physical priors UPPs to simulate the underwater imaging. After that, the selected reference feature is further refined by our RFVM to obtain the refined reference feature based on their similarity map. To construct the underwater dictionary, we first select some representative underwater images to cover the most comprehensive common objects of underwater images. After that, they are sent to the pre-trained Deep Image Compression Network DICN to extract its compression features at multiscales. Then, we adopt k-means to compact the features in dictionary. Finally, k-typical features at each scale are preserved, constructing our multiscale feature dictionary. Feature match aims to select the reference features that have the most similar textures to the input features and are not disturbed by multifarious underwater styles. By studying the underwater imaging model shown in equation 1, we infer the normalization equation 3 and propose the USNB to parametrically implement equation 3. Although the reference and input features share some similarities, the relative position of the similar areas in them may be dramatically different. Hence, we designed the RFVM to adaptively morph the reference feature based on the input. RFVM utilizes the SVRNN to implement the feature variant on a large receptive field, and their weights are the dependency map learned by dilated convolution compression methods on 4 underwater image test sets. As shown in the RD curves, our RD curves are above the curves of all comparative methods on 4 test sets, which demonstrates our excellent performance and generalization. Additionally, our RFD-ECNet is compared with the latest video codecs. As shown in Table 1, we achieve better results than both VVC and HEVC at intermode, verifying that our RFD-ECNet is more efficient than video codecs to remove redundancy between underwater images. Table 2 present our ablation results. As shown, the removal of either USNB or RFVM degrades the performance of our RFD-ECNet. Moreover, the performance degrades most when USNB and RFVM are removed simultaneously, verifying the effectiveness of the proposed USNB and RFVM. Lastly, we present visual examples reconstructed by different methods. As shown, when BPP equals 0.049, VVC intra, Cheng and JPEG 2000 completely lost the common object of sand, while our RFD-ECNet can roughly reconstruct the sand by referencing our dictionary, indicating our excellent compression performance.